Hi, welcome to week 2. This week we're going to again be talking about motion, but not just how things move in one dimension. We're going to be actually talking this week about two-dimensional motion, motion in two dimensions at the same time, as well as what causes motion, namely forces. So let's start about talking about two-dimensional motion. When I say two-dimensional motion, what I mean is not just moving back and forth along a straight line, forward and back. I mean motion where, for example, let's say here's a little axis. I'm starting off here, and I end up over here, and I move in both the x and the y direction. That's two-dimensional motion. So not that you move straight north or straight west, but that you move northwest. How am I going to handle that? We talked about all these relationships last week in terms of acceleration, velocity, and position. Well, that all applies here in two-dimensional motion as well. Think of two-dimensional motion as one-dimensional motion twice. So I can think about my motion here as being purely some motion in the y direction, and I can think about it as being some motion in the x direction. And if I solve that problem twice, a purely y direction problem and a purely x direction problem, I will have solved a two-dimensional problem. Why? Just the way it works. Welcome to math. So part of your homework this week in WebAssign is going to be doing the same stuff you did last week, only now in 2 dimensions instead of 1 dimension. Should be no problem. Again, if you have questions, make sure to click at the button at the top, ask me some questions. I'll get back to you as soon as I possibly can. The second part of the unit this week, which I think is a lot more engaging in many ways, is about forces, or what causes us to move in the first place. When you talk about force, you have to talk about Sir Isaac Newton. Newton came up with, among many other things, Newton's laws. What are these? These are essentially 3 principles by which we can direct the nature of force and what it means in terms of motion. You've probably heard of at least one of these before, but let's go through all 3 of them just so we're all clear as to exactly what they are. So let's begin with Newton's first law. Newton's first law says that an object in motion will stay in motion, or an object at rest will stay at rest unless acted upon by an outside force. What that means is if I have something stationary and there are no net forces applied to it, it's going to stay exactly where it is. It also means that if something is moving along at a constant speed in one direction, that it's also going to continue moving on at that constant speed in that same direction unless acted upon by a force. Pretty straightforward, right? Okay. So it's one-dimensional or two-dimensional or three-dimensional, but we haven't gotten to 3D yet. That's next week. Three-dimensional, that an object at rest stays at rest, or an object in motion stays at motion unless acted upon by an outside force. Newton's second law really describes how that force works. And Newton's second law can be written many different ways, but the most common way to refer to Newton's second law is by F equals ma. Don't be too caught up on this. This is just simply a statement in mathematical language of a basic principle that the acceleration of an object of a mass m is proportional to its force. And in fact, if we're using units of meters, kilometers, seconds, kilograms, then that force is going to be exactly equal to the mass times the acceleration. What does this mean? This means that because the acceleration is a vector, the force is also a vector. Remember, a mass is just a unit quantity. It's just a property of a given object. So force is equal to mass times acceleration. That's Newton's second law. Newton's third law is that each action has an equal and opposite reaction. What does that mean? It means that if I push on you, you effectively push back on me with an equal and opposite force. So if I take this marker and I drive it into my hand, the marker is having a force on my hand. My hand is also having a force back on the marker. an equal and opposite force is always the same kind of force. People often find it easy to think of an object sitting on a table, for example, as having Newton's third law forces of the force of gravity pulling the marker down and the force of the table pushing the marker up, and those are the equal and opposite forces. They are not. The force of gravity pulling down is in fact a force of gravity, and its equal and opposite force will also be a type of force of gravity. So the force of the marker pushing down is the marker's attraction to the center of the Earth. The equal and opposite force for the marker being pulled down is the Earth being pulled up to the marker. Now, you're very commonly aware of the marker dropping due to the force of gravity. You don't really think often of the fact that the Earth is going to be moving up to the marker. Why? Well, remember Newton's second law. Force is equal to mass times acceleration. Marker, very small mass. Earth, very, very large mass. So when you're looking at the two of them, chances are you're going to see the marker moving a heck of a lot more than the Earth. So what is the equal and opposite force here? So the marker has a force of gravity pulling down. The Earth has a force of gravity from the marker pulling up. Those are the equal and opposite. What about the table? The table has a normal force, a force pointing up from the table surface, holding it up. And then the marker actually has a force onto the table. The marker is pushing on the table with a force pointing down. So those are two examples of equal and opposite forces. This week during your discussions post, you're going to find an example of a force from one of the videos that you've seen in the previous 2 weeks. Identify what kind of a force it is, why you can identify that a force is taking place, and for an example where you have two objects that are touching each other in some way or colliding or interacting with each other, I want you to identify the Newton's third law in example of the action and the reaction. What is the force and what is the opposite force coming back?